Hi class, in this video we're preparing for our quiz on probability. First problems, the key is that to find simple probability, our formula is that it is parts to whole. So based on this formula, we can calculate these different probabilities. The next problem say, given the universal set U is the natural numbers from 1 to 20, so the counting numbers from 1 to 20, determine which of the following diagram represents the relationship of the two defined sets. Okay, so multiples of 5 going from 1 to 20, so that'd be 5, 10, 15, and 20. The even numbers would be 2, 4, 6, 8, 10, so we see that the relationship for this first one would be 2, because, for instance, they would share some even numbers such as 10 and 20, 10 and 20, but then it would not share numbers like 5 and 15. For the next problem, comparing multiples of 4 with odd numbers, those are mutually exclusive, so that's relationship number 1. For the second, for part C, we have set A is the numbers less than 4, so that'd be 1, 2, and 3. And then set B is multiples of 4, so that would be 4, 8, 12, 16, and 20. So therefore, those are also mutually exclusive. Those have none in common, so that's relationship 1. For the next problems, we have to shade the region for set B. So the key when we shade this is that, yes, we're shading that intersection because that intersection is in the B group. And the next problem, we're shading set A or set B. So we're shading the union, where the union is both sets, including the intersection, because the intersection does meet at least one condition. In the next Venn diagram, the A stands for students who are in algebra, and the B stands for students who are in biology. Okay, so for the algebra students, we can see that, for instance, there would be 26 total algebra students. So 15 does not represent all of the algebra students. It just represents the algebra students who are not in biology. That's the key. But this first problem says the number of students who are in both algebra and biology. So that's the intersection, that's 21 students. The number of students in algebra or biology, that would be the union. So that would be 15 plus 21 plus 11. So if we add up that list, then we'll have 47 students. For the number of students not in biology, then that would be 15. But we have to also add the 7 students who are not in algebra or biology. So altogether, there are 22 students not in biology. And the total number of students, if we add up all those, we have 54 students total. In the next problem, events A and B are independent. So assuming that these are independent, the probability of A is 50%, probability of B is 30%, so the probability of both happening would be multiplying that together, so that would be 15%. But if A and B are not independent, so if they're dependent, and A is 70% and B is 50%, then in this case we do not have enough information, because in our Venn diagram we don't know how much those two circles are going to overlap. We don't know if it's just overlapping a little bit or if it's actually overlapping a lot. That would all depend on what those two sets would happen to have in common. Next problem says, if event A, your height, and event B are independent, which of the following could possibly be event B? Alright, well, those two events have to be independent. They have to not be related to each other. So height would not be related to eye color. eye color, for instance. So for grade level, then height would be related, for instance, maybe not in high school, but comparing a first grader with an 8th grader. The length of your arm, also thinking of small children, and height relating to age for small children also. So eye color would not be related to height. For the next situation, if events A and B are independent, then which of those following things are true? They're not going to be mutually exclusive. They are going to be overlapping. Multiplying the probabilities is not going to equal 1. That would be the case of complements or the not operator. Alright, so but multiplying the probabilities will be the probability of both things happening, so that's why it is C. Next problem, the given two events, events A and B, are independent events. Probability of A is 0.42 and probability of B is 0.3, so the probability of both. We could get these answers by multiplying the probabilities together. The next one says, what's the following represents the probability that B happened, or that B happens given that A happened. So since it's given that A happened, then we're only going to look at the A set. So on this one, here's our A. So on this one, here's our A set. And of that A set, then A and B would be the part where the B would happen. So the probability of B given A is the probability that A and B happen, this section here, compared to the whole A. Next, question 11. If events A and B are independent, which of the following is false? If they're independent, then yes, multiplying them together is the probability that both things happen. Here, yes, since A and B are independent, then A is not related to B, so given that B happens, it doesn't matter. Probability of A is A. Same with this. It doesn't matter that A already happened. Probability of B is B. So the problem here is that edit right there. That should say the probability of A. So that would correspond with that A there. So that's why the answer to this question is B. Next question, probability of A given that B happened does in fact mean that the B has already occurred, so that's true. Next problem, probability of both happenings 0.3, probability of B is 0.5. So what's the probability of A? Okay, so we could work backwards and have that 0.3 divided by 0.5 is going to be 0.6. So that's the probability that A happened. Next problem, so assuming that these are independent, that means that it doesn't matter that B happened. The probability of A is 0.35. So that answers our question. Similarly with this one, it doesn't matter that A happened. Probability of B is 0.32. These problems were determining the missing probability and then determining if they're independent or not. Marking up my Venn diagram, okay, so I have 0.1 in the middle. Now when I mark this up, the whole of A is 0.4, so I'm just going to mark that the remaining section is 0.3. Then I can clearly see that the 0.3 plus the 0.1 is the 0.4. Then the probability of B is 0.25, so I'm going to put a 0.15 here, because 0.15 plus the 0.1 is the 0.25. So now I've marked up my diagram. Now I want to find the probability of B given that A happened. So what that means is that I'm just focusing on the A section right here. So in that A section, the total is 0.4. And the part in which B happens is 0.1. So 0.1 divided by 0.4 is 0.25. So that's my probability that B happened given that A happened is 25%. And when I compare that, the question is, does that equal the probability of B? And our answer is yes. So since those are in fact equal, that shows that this is an independent situation. Another example, I'm going to first mark up my Venn diagram. Okay, so I have the 0.3 being shared as the intersection. A and not B is 0.45. So that's in the A circle, but not in the B circle. So that goes right there. A or B is 0.85. So since the whole union is 0.85, and so far I've used 0.75, that last section must be a 0.1. So I've marked up my Venn diagram in the missing spots. Okay, so now I'm looking for the probability of B given that A happens. So again, I'm going to just focus on the A circle. And the whole, the total probability there, I can see is 0.75 because that's just this 0.45 plus the 0.3. So that's 0.75. But the probability of B happening within that circle is limited to just that intersection, this section right here, which is 0.3. So 0.3 divided by 0.75 is equal to 0.4. And the question is that the probability of B happening? So when I look at my Venn diagram and I look at my B, I have 0.3 plus 0.1, so that is in fact 0.4. So that verifies that yes, this has to be an independent situation because the probability of B given that A happened is the same as the probability of just plain B, meaning that it doesn't matter if A happened, meaning that these events are independent. Large and small businesses were surveyed about the type of printer that they use. Okay, so what's the probability that the printer will be a Canon printer? So the total Canon printers are going to be 153. 153 divided by the total, which is 254. The next question says, what's the probability of Xerox and large? Okay, so assuming that the business is large and that it's a Xerox, then that will be 78 total, still out of that total of 254. What's the probability of a small business having a Canon printer? So we could see that that number is 99. The small business in the Canon is 99 out of 254. What's the probability of a Canon given that it's a large business? So for this different problem, we're just going to look at the section of the large businesses. And we could see that in that section, 54 of the 132 large businesses have a Canon. So notice that for this problem, we're finding the conditional probability, and it's out of the total. The total is now the large business of 132 instead of the prior total, which was 254. So for the next one, the probability of a small business, given that it's Xerox. So given that it's Xerox, the total Xerox are 101. That's our total. And out of that, the small would be 23. So 23 out of 101. The last one, what's the probability of it being a small business or a Canon? Okay, so the total for a small business is 122. The total for a Canon is 153. But when we do that, we see that we add up that number 99 twice. So we have to take away small and Canon, that 99. Doing that calculation, we'll get 176, and that's out of a total of 254. The next question says, are being a large business and using a Canon printer independent? Yes or no? Okay, so what I want to see is the probability of A and B equal to the probability of A times B. If this is true, then it is in fact an independent situation. Okay, so the probability of A and B happening. Okay, so in that case, so large business in Canon, large business in Canon is 254. I'm sorry, is 54. It's 54 out of the total 254. So that's the probability of both things happening. The probability of a large business is 132 out of 254. And the probability of the Canon is 153 out of 254. Okay, so when I multiply these out and just change it to decimals, I have, for the first part, I have 0.212. Is that equal to multiplying the fractions and getting 0.313? So since these are not equal, that shows that no, this situation is not independent. The next questions ask about replacement. So, given that a green marble was selected and replaced, we're back to the situation that we started with. So that green doesn't matter. The probability of a blue is 5 out of a total of 10, which is 1/2. Given that a blue was selected and kept, okay, so we're keeping the blue, that means we're down to 4 marbles there. So now the chance of picking a red is 2 out of 9 total. The probability of A or B happening is the union events A and B. So that's making the connection between or in union and in intersection. Okay, next question 18. The probability of A plus probability of B is equal to probability of A or B is false. It's false when events A and B are sharing elements. So for the case when those are overlapping, then we have to take away the probability of both happening in order to fix the equation. Next questions, we're looking to determine the probability. So we're going to add up A plus B, but then take away A and B. So that's 0.21 plus 0.35. Take away 0.12. So doing that calculation, we'll get 0.44. For the next one, it says that the events are mutually exclusive, meaning that they do not overlap. Therefore, we can just add 0.17 plus 0.33. So together that equals 0.5. This part C says that A or B is 0.7. A and B together are 1.1. So 1.1 minus 0.7. The overlap section must be 0.4. The teacher asks, what does it mean for two events to be independent? Jennifer raises her hand and responds, it means that the two events have no elements in common. Is she correct? She's not correct because she's confusing it with mutually exclusive. That they're not going to share any elements. So for two events to be independent means that one event has no bearing on the second event, such as spinning a spinner and rolling a die. It is possible to spin a red 3 and have both things happen. Good luck on your quiz.